A customer recently tricked a Chevrolet dealership's automated chatbot into agreeing to sell them a brand new 2024 Tahoe for exactly $1. That's an amusing oversight, but the stakes scale up quickly. A lawyer submitted a legal brief to a judge, entirely written by an AI, only to discover that the court cases cited in the document were completely fabricated. When we see failures like this, we tend to project human traits onto the software. We assume the AI is confused or actively lying. But these large language models are not conscious agents capable of reasoning. They are complex, mathematical generation engines. People often call these outputs hallucinations, implying the system is experiencing a glitch. It isn't. The AI is functioning exactly as designed, mathematically generating the sequence of text it calculates you want to see. Because these models are essentially people-pleasing prediction engines rather than reasoning minds, deploying them into high-stakes environments, like legal defense or binding financial contracts, creates a massive accountability gap. In the 1990s, a PhD researcher's neural network project might run on a basic desktop computer and contain between 30 and 3,000 individual neurons. Fast forward to the deep learning renaissance that kicked off around 2017. The core mathematical principles are largely the same, but they have been scaled up into massive, energy-hungry large language models containing billions of parameters. The math hasn't changed, but the sheer scale and speed of modern models have stripped away our ability to easily understand or control how they produce their outputs. To evaluate these applications, we can map them. This graph plots the potential reward of an AI project along the horizontal axis against the risk of that project on the vertical axis. In the bottom left quarter, you have low-risk, low-reward tasks, like an AI completing a line of code or suggesting text revisions. In the top right corner, you have extreme high-risk, high-reward concepts, like an automated AI judge or full artificial general intelligence. The middle area is where things get complicated. Take a recent test where a user asked an AI to write a database query for a genealogical tree. The model generated SQL code that perfectly tracked the mother's lineage, but completely ignored the father's. Encountering an anomaly like that raises a difficult question. Is this just a harmless coding bug, or is it a manifestation of systemic gender bias baked into the training data? Because the internal logic of a deep learning system is hidden, we cannot simply ask the model why it dropped the data. Identifying and correcting subtle biases becomes a dangerous guessing game. This opacity leads directly to a compounding problem known as AI slop. This occurs when an AI generates slightly flawed or degraded content, which then gets published to the wider internet. Future models scrape the internet for fresh data and ingest this degraded text. It functions exactly like a Xerox machine copying a copy. With every rotation of the cycle, the quality of the information breaks down a little bit more. Once that data is absorbed, the damage is essentially permanent. Recent research indicates that large language models cannot easily target and unlearn information once it has been integrated into their complex network of weights. Without strict human intervention, the very data fueling the AI revolution will eventually become the poison that breaks its reliability. Governments are attempting to step in. The European Union passed the AI Act to mitigate these risks, outright banning unacceptable technologies like social scoring or biometric identification in public spaces. However, the legislation contains a major technical flaw. It includes a legal requirement for explainability, demanding that developers prove exactly why an AI system made a specific decision. That legal demand is theoretically impossible. You can observe the mathematical weights, but you cannot extract a philosophical explanation from an emergent self-organizing system. Forced to comply, engineers rely on superficial guardrails instead of true explainability. If a chatbot keeps recommending another brand's vehicles, developers simply write a hard-coded prompt filter commanding the AI to not mention competitors. The law demands a clear philosophical explanation for AI behavior, but engineers can only provide blunt mathematical guardrails. If we can't fully explain how an AI thinks, could we just program the system to take a Hippocratic oath and force it to do no harm? No. Because the AI is a people-pleasing prediction engine without consciousness, it will gladly lie, cheat, and claim it is aligned with your rules, even when it is actively breaking them. The Hippocratic oath isn't for the machine. It is for the human researcher, the developer, and the engineer. Your AI is your responsibility. You cannot outsource morality to math. If you build it, you must be the one holding the red stop button. Taking that responsibility seriously requires understanding the underlying architecture. If you want to build the future safely, you have to master the tools first. To gain the technical skills required to build AI responsibly, head over to the Learn by Doing with Stephen channel on YouTube and other video platforms. And for deeper conversations on the trends and ethics of data science, check out the Stephen Data Talk podcast on YouTube Music, Spotify, and Apple. All the links are waiting for you in the description.